Full harvest moon night. Gather around, play and dance. Red, white, and black. In the last episode, we completed the goldfish object. In this episode, we'll instance them as a flock using flock controller. There is something left unfinished, so let's take care of that first. I want to be able to adjust the starting position for pectoral fin. So go into Make Pectoral Fin and find the part that drives the animation. Insert an add after this multiply. Then connect to group input and rename the argument to movement offset. Tab out and connect it to the group input movement offset. Now, let's hide the plane object that holds a goldfish. Unhide the Bezier curve and select. We will start working on this geometry node. First, let's instance the goldfish as we did with Suzanne head. Delete the object info, then drag and drop the plane. Connect the geometry to instance socket. Let's change the direction and size by adding a transform geometry. Then, enter 90 for Z rotation and 0.5 to all scale. Animation will look with decent looking flock movement. Let's tune the parameters for a better look. H noise scale 0.3, H noise gain 1, V noise scale 0.1, V noise gain 2, look ahead time 0.5. Goldfish is now moving smoother than before. Alright, round and round they go. However, I'm very discontent with this motion. Look at how they all move the same way. So unrealistic. I'll go into edit mode and replace the circle with Bezier for better view. As you can see, all fish are synchronized perfectly. The instance on point within flock controller is only copying and pasting single object to different points. This motion is understandable since all the animation reference is the same, but I don't want this as my final result. So here's my bullet point number 2. Multi-object instancing. I want each goldfish to have its own unique motion. Instead of simply having one object to be instanced, I'll instance different objects on points. At this point, some of you might be thinking, wait a minute. But I will address that concern later, so let's just try things out. So, let's first delete this object info and replace it with goldfish node group. We can get the same effect as before by connecting it to transform geometry. Let's add the color back in by entering 0.5 for both red and black factor. We'll then insert a geometry to instance after transform. This will cause each goldfish to become its own instance. Next, within flock controller, we'll turn on the pick instance option for instance on points. Then tab back out and create some space here. Add a repeat zone and spread it apart. Then open up the side panel and go to the Node tab to add an iterator. Change the data type to integer. Add one to the iterator and connect it to the output side. Next, place a join geometry on top of the geometry connection. Then, connect the geometry to instance node output to bottom of join geometry input socket. Connect the repeat output to instance. Next, connect count and seed to empty socket of group input. And duplicate the group input to the left of repeat zone. Plug in the count to iterations to make all goldfish separate objects. It doesn't look like anything has changed, since parameter settings are the same for all the fish. So let's start off by changing movement offset for each fish. Make some space and connect the random value to movement offset. Enter tile into max, then connect iterator to ID. And group input seed to seed. Body pose is now different per goldfish. Though it is supposed to be different, they appear to be synchronized. Well, not only synchronized, but they seem to be in clusters. Here, here, and here. We can see clusters of same motion. Well, this is a phenomenon I called biased random values. To explain, I'll first go to where random values are used the most. Let's go to flow control. We're using 4 random value nodes here. Let's take initial position and speed as an example. Random number generator using the same seed and ID will always result in the same number. This random value node then interpolates the output between min and max to get its final value. So, let's say a fish A with certain index and seed resulted in initial position of 0.3, and fish B with different index and seed resulted in similar position value of 0.299. Even if the node is different for speed calculation, fish A will result in speed value of 0.3 due to the same inputs. And fish B will also end up with speed value 2 of 0.299. Since both fish A and B have similar position and speed values, they end up clustering and synchronizing. In order to avoid this bias, what we want to do is change the seed value used for different random value nodes. It's cumbersome to assign different seed per node, so we'll just multiply certain value for each random value input. Make some space after the group input and insert a multiply. For this initial position, we'll just multiply the seed by 10. Similarly, for speed random, make some space after group input. Then insert multiply and enter 20. This will cause random number generator to output different result for speed. Do the same for horizontal noise. Multiply by 30. Same with vertical noise. Multiply by 40. Tab out to the top layer. Let's do the same for movement offset and insert multiply. Use 50 for its multiplier. When we run the animation, we can confirm that the clusters are gone. We can compare the result by changing the seed value to 0, since multiplier won't work with 0. There are obvious clusters with seed of 0, whereas we no longer can spot them when seed is set to 1. Alright, let's add more variations by adding randomness to movement speed as well. Duplicate the multiply and random value nodes with Ctrl-Shift-D. Bring them up and set the min max to 4 and 6. For the multiplier, we'll use 60, then connect the result to movement speed. Add some variation to color as well. Duplicate as before, set the min max to 0 and 1. Set the multiplier to 70 and plug it into red factor. Duplicate, enter 80, then connect to black factor. We want some variations for size as well, so let's go into Flock controller and change the scale. Connect the random value to instance on point scale. Set the range at 0.8 to 1.2 for all directions. Use index for ID. Then connect group input and mass multiply to seed. We'll use the value 90 for multiplier. Alright, so we now have variations in size, color, and movement. Let's now address the elephant in the room, processing load. So, the instancing mechanism used in instance on points is highly efficient due to the way they copy and paste single object. What we are doing here is sacrificing efficiency to add variations. Let me just demonstrate how efficient single object instancing is. There is no need to follow along here, but I'll start off by duplicating these 3 nodes. When I plug this into flock controller instead of repeat zone, it is back to single object instancing. Let's display the timing overlay and run the animation. So with single object, it takes a little less than 2 milliseconds to compute. Even if I increase the count to 50 or 100, it is roughly the same. Even at 1000, computing time for geometry node only takes about 3 milliseconds and no effect on FPS. At 5000, there is a dent in FPS, but it is only caused by rendering. Still smooth with solid view. Let me switch it back to multiple objects. Starting at 10, timing is already at 50 milliseconds. At 20, it still runs. 50, there is already some drop in FPS. Geometry node is taking more than 50 milliseconds to compute. At 100, we are hitting the limit, even with rendering off. At this point, you might be asking, why should we use multi-object when we want to make a flock? Well, it is because using single object creates this unrealistic synchronizing abomination, which I refuse to call a flock of fish. Look at this. This is not a flock. It's a single entity. Well, so what should we do? Answer is simple. We'll limit the amount of variations so we can keep the load low enough, yet make them look unique. I'll revert the changes so we can work on it together. It's quite a simple change anyway. Currently, our repeat zone iterations is connected to counts, but we'll reconnect to an empty socket instead. Change the argument name to variant count and reorder. Since the value is set to 1, it is the same as single object instancing. When we set the value to 2, exactly half of the fish changes to different variation. Setting it to 3 makes equal number of 3 variants, so forth and so on. Setting it to 10 will make all 10 fishes different. At this point, even if we set instance count to 100, there will only be 10 fish variants created. Of course, there will be fishes that synchronize, since there are only 10 patterns, but if we see them as a whole, it is much an improvement over single object instancing. Okay, since there is no reason to create more variants than instance counts, I'm going to limit the iterations. Add a mass minimum, then connect count and variant count. Plug it into iterations. Let me decrease the count to 50 because this is way too much. Okay, Select these nodes and Ctrl-G to group them. We'll rename the arguments from the side panel, change iteration to counts, value to seed, and also set the type back to integer. Tab out, then change the node group name to Goldfish Factory. We'll also plug the arguments for Flock controller to group inputs to make them externally controllable. In the edit mode, delete the Bezier curve and replace it with circle. Increase the radius a bit for more space. Let's set the H noise gain to 2, since I think it gives a little bit more space for movement. So the color scheme for the flock looks a bit shifted towards black. You can change the random value min, max, in Goldfish Factory to adjust the coloring ratio. Set it to your liking. We'll take a final look at the animation. Starting to look pretty good. We should be almost done. Alright, let's go over what we made so far. The top layer. Goldfish Factory we worked mainly on. Make pectoral fin. There were some unfinished business. Flock controller. Make sure pick instance is turned on. Lastly, flow control. We added some multipliers to avoid random bias. We instanced the goldfish and added variations. In the next episode, we'll make the movement speed variable and sync body animation to its speed. Thank you for watching. See you in the next one.